This video will focus on circular and periodic functions. So let's talk about periodic functions first. A periodic function, if we're looking at the graph of a function, it's when it starts to repeat itself as you go. So if we're looking at this function, if we're looking at this piece looks like it's about to repeat itself again and again. And if you think about copy and pasting this piece to this piece, it would overlap itself perfectly. So let's say this distance was 10. We would then say the period of this function would be 10 units. So if we're thinking about the period, that would be the amount of distance until the function begins to repeat itself. And once you have a function that repeats itself, that would make it a periodic function. That's all that a periodic function is one that begins to repeat itself. So if you look at a function like, say, y equals x squared, that would not be periodic because there is no repeat here. A place where we see periodic functions very naturally is on the unit circle. And we already know that on the unit circle, if we look at the height of this triangle that's made, this would be our y coordinate for this blue point up here. Likewise, our x coordinate for this point, the blue point, would be right here. We know both of these change depending on this angle. Let's call it theta. And we know that on a unit circle, y equals the sine of theta, and x is equal to the cosine of theta. So if we look in particular, as this goes around, once we hit 360 degrees, it'll start to repeat itself. So if we're looking at the sine of 90, that would be the same as the sine of 450 degrees, so on and so forth. And both of these x and y coordinate are dependent upon a third variable, theta. And in later lessons, we'll look at what the graphs of sine of theta and cosine of theta look like. But for now, we're just kind of thinking on a general scale as an example of what one would look like naturally.